Hello friends, so after completing the first problem on linear dependence and independence, let's move ahead with the second problem. Now in this problem, we have four different vectors and we have to show that the fourth vector is linearly dependent on other three vectors. So here we have to show that the vectors x1, x2, x3 are linearly independent and the vector x4 depends on those three vectors, that is x1, x2 and x3. So guys, to solve this problem, we have been given four different vectors. Now let's start with the first part, that is we'll show that the vectors x1, x2 and x3 are linearly independent. Now guys, whenever we want to show the given vectors are linearly dependent or independent, what we have to do is we have to consider the matrix equation. So first of all, I'll consider the matrix equation for the vectors x1, x2 and x3. Now guys, here the value of x1, x2 and x3 is given in the question and I'll substitute those values in this equation. So we'll get, to prove the linear dependence or independence, we have to find the matrix form of these given equations. So to form the matrix form, we have to first find out the equations. Now how to get the equations? So to get the equations, we'll multiply the first element of each vector with this coefficient and will form the first equation. Then we'll multiply the second element of each vector with the constant, we'll get the second equation. So similarly, we'll get three equations over here and from those three equations, we'll get the matrix form. So the first equation will be 1 into k1 plus 2k2 plus 0k3. So for the second equation, we'll multiply the second element. Now guys, we'll convert these three equations in the matrix form. So in the matrix form, we have a form as Ax equal to B, where A is a matrix of coefficient. This matrix X is a matrix of variables and B is a matrix of constants. So to get the matrix of coefficients, we'll write down all the coefficients of the equation. So the coefficients are 1, 2, 0, that will become first row, 2 minus 1, 1 will become second row and 4, 3, 2 will become the third row. Now this capital X is a matrix of variable. So in our case, the variables are k1, k2, k3. So we'll get, and we got B as all zeros since in our equation the constants are 0. Now after getting the matrix form of the equations, we'll convert this matrix into echelon form. Now to get the echelon form, we'll first make these two elements as 0. So the element in the first column will make 0 except the first element of first row. So to make these two elements as 0, we'll subtract this row number 1 from row number 2 by multiplying this row number 1 with 2. So we'll say by R2 minus R1. So by doing this, we can get 0 here, and then we'll do R3 minus 4 times R1. So by doing this, we'll get 0 here. By doing this, 2 times R1, that will become 2, 2 minus 2, 0, 2 times R1, this will become 4, so minus 1 and minus 4, that is minus 5, and then 2 times this is 0, so 1 will remain as it is. Next 4 times of R1, so 4 times minus 4, 0, 4 times of this is 8, so 3 minus 8 is minus 5, and 4 times of this is 0, so 2 will remain as it is. Now guys, after getting zeros here, to get the echelon form, we should get 0 here. So we know that in echelon form, we should get the more number of zeros in each row as compared to the previous row. So in the first row, there are no zeros. In the second row, the first element is 0. So in the third row, we should get these first two elements as 0. So to get 0 here, we'll subtract this row number 2 from row number 3. So by doing that, we'll get 0 here. Now guys, if we'll subtract this row number 2 from row number 3, we'll get 0 here. This minus 5 minus minus 5 will be 0 here, and here we'll get 1. So here we'll get 0, 0 and 1. Now guys, you can see that this equation or this matrix has been converted to the echelon form, and after that we'll again convert this matrix form in the equation form. So the first equation will be k1 plus 2 times k2 plus 0 k3 is equal to 0. Then second equation would be minus 5 k2 plus k3 equal to 0, and the third equation will be k3 equal to 0. Now guys, since k3 is 0, we'll put value here, we'll get k2 as 0, and since k2 k3 both are 0, we'll get k1 as 0. So it means we'll get k1, k2 and k3 all are zeros. And we know that whenever we get k1, k2, k3 as zeros, then we say that the given vectors are linearly independent. So we have seen this in the concept of linear dependence and independence. So since these three values are 0, we'll say here that the given vectors are linearly independent. So we have proved the first part. Now let's move to the second part. So after showing x1, x2, x3 linearly independent, the second part is we have to show that the x4 is dependent on these three vectors. And guys, for that reason, we have to consider the x4 now. So what we'll do is, now we'll consider x1, x2, x3, x4 and we'll form new equation or new matrix equation. So for these four vectors, the new matrix equation will be k1 x1 plus k2 x2 plus k3 x3 plus k4 x4 equal to 0. Then we'll substitute the values of x1, x2, x3 and x4. Then we'll convert that into the equation form. And after the equation form, we'll convert that in the matrix form. So guys, what I'll do is, here I will not consider these two steps. I'll directly write down the equations that we are gonna get. So just imagine here we have k1, k2, k3 and k4. So equation will be like this: 1 into k1 plus 2 into k2 plus 0 into k3 minus 3 into k4 equal to 0. So that's become our first equation. So now let's find out the second equation. So that will be 2k1 minus 1k2 plus 1k3 plus 7k4. Now let's find out the last equation. So 4k1 plus 3k2 plus 2k3 plus 2k4 equal to 0. So here we got the three linear equations, and now we'll convert these linear equations in the matrix form. So in the matrix form, we have first matrix as a matrix of coefficients. So here the coefficients are 1, 2, 0 and minus 3. In the second row, that will be 2, minus 1, 1 and 7, and the third row, that is 4, 3, 2 and 2. Then we have matrix of variables. So here the variables are k1, k2, k3 and k4. And the right hand side is matrix of constant. So all constants are 0. Now guys, after getting the matrix form, we have to convert this matrix A in the echelon form, and for that we have to bring zeros here. So to get 0 in the row 2 and row 3, we'll subtract this row number 1 from 2 and 3. So we'll say R2 minus 2 times R1 and R3 minus 4 times R1. So by doing these two operations, we can get 0 in the first column. So guys, if I do R2 minus 2 times R1, so here it will be 0, then 2 times of this is 4. So minus 1 minus 4, that is minus 5. Here 1 will remain as it is, and here 2 times is 6, so we'll get 13 over here. So now 4 times of R1 and we'll subtract it from R3. So here we'll get 0. 4 times of this is 8. So 3 minus 8 is minus 5. Here we'll get 2 only. 4 times of this is minus 12, and here we'll get 14. Now to get the echelon form, we should bring 0 over here. So to bring 0, what we'll do is we'll do R3 minus R2. So guys, by doing R3 minus R2, we'll get 0, here 0, here we'll get 1 and here we'll get 1. So guys, here we got the echelon form, and if you observe, then all three rows are non-zero, and that is why we can say that the rank of this matrix is 3. So we'll convert this matrix form into the equation form. So first equation will be k1 plus 2k2 minus 3k4 equal to 0. The second one is minus 5k2 plus k3 plus 13k4 equal to 0. And third one is k3 plus k4 equal to 0. So guys, here we got the three equations. Now to get the linear dependency and independency, we'll assume k4 as t. So by assuming k4 as t, we'll get k3 as minus t. Now we'll substitute the values of k3 and k4 over here. So this will become minus t, and here we'll get 13t. So 13t minus t is 12t. 12t will go here, and that will become minus 12t. So we'll get minus 5k2 is equal to minus 12t. Now by solving this, we'll get k2 as 12t upon 5. Now the value of k2 and k4 we can substitute over here. So k1 plus 2 into 12t by 5. So we'll get k1 plus 24t upon 5. Here k4 is t, so we'll get minus 3t equal to 0. By solving this, here we'll get minus 15t upon 5. So 24t minus 15t, so that is nothing but the 90. So we'll get k1 plus 90 upon 5 equal to 0. And that is why we can say that k1 is equal to minus 90 upon 5. So guys, here we got all values, that is k1, k2, k3 and k4. Now we'll substitute all these values in the matrix equation. So the matrix equation that we have considered initially, that is k1 x1 plus k2 x2 plus k3 x3 plus k4 x4 equal to 0. In that we'll put different values of k. So we'll get, now guys, from this equation we'll take t common. We'll shift that t to the right hand side. So 0 upon t will become 0. And in the remaining equation, we'll just keep x4 on the left hand side. So let's see. So if we keep x4 on the left hand side, and if we shift these three values on the right hand side, this will become positive, this will be negative, and this will be again positive. So we'll get, so we have proved that x1, x2 and x3 are linearly independent, and the vector x4 is dependent on x1, x2, x3 with this relationship. So guys, I'm sure you understood the explanation, and you are gonna copy paste this explanation in the examination to get the full marks. And don't forget to share this channel with your friends, because here we are putting new content every day, and you can spread this content to your friends so that they can also get benefited through this ekeeda.com. Thank you very much.